Okay, well, thank you for tuning back in. This is going to be labeled as Section 6.5 Part B, even though Part A was really just me saying watch a different video. But let me just kind of write that up here really quick. So this is Part B. And you know, the unit circle should be filled in at this point, but here's the deal. I'm going to look back at it and talk a little bit about it in just a moment. But let me first kind of fill in the vocab in this box. It says, first of all, unit circle, a circle centered at the origin, or 0, 0. So that's kind of probably figured out very quickly, origin. With a radius of 1, and I know on that con video they really were like, hey, just so you know, we have a radius of 1. That's kind of why we call it a unit, a single unit circle. The x-coordinate of the point is always going to be, of the unit circle, is going to be the cosine. And so every point on that circle going around is, that's the x-coordinate, is a cosine of that given angle, which is super cool. And the y-coordinates relationship is going to be the sine. And tangent, which kind of confuses students, even when I'm teaching pre-calculus. It just, I don't know what it is about tangent, but it's really just taking the sine of a given angle over the cosine of that given angle. Now, in terms of just x, y coordinate points, it's just taking the y and putting it over the x, because if you look here, the y is associated with the sine, and the sine is in the numerator, and the cosine, which is associated with the x, is in the denominator. So these really, this and this, really are saying the same exact thing, just different form. And this is huge when we get into vectors and everything, really everything to do with trigonometry as we move forward. So it's really important that we just understand what this unit circle is saying. And of course, that con video talked about where those values are coming from, and kind of taking a step back. Now, my unit circle probably looks a little different than yours, but let me just kind of highlight some of the major important components of it. So again, kind of like we said in the box, the x is going to be, and you're not going to see what I'm pointing at. Actually, how about I highlight it? The x is associated with the cosine of theta, the y, the sine of theta, and then the tangent of theta is going to be your y over your x value, or the other thing you can think of is your sine over your cosine. Now, again, that video was so important because really Saul had got into where these values are coming from. And of course, now you know that you're talking about a 30, 60, 90 triangle, and we have certain relationships within that 30, 60, 90 triangle, and of course the 45, 45, 90. And really all these unit circles are coming, or the points on this unit circle are coming from the special triangles that you learned in geometry. So again, you might want to pause me if you didn't watch that video really well, because you definitely need to see and understand where these values are coming from. But what I did with this unit circle is kind of color-coded it for both you and I's sake. Everything in green is dealing with angles of rotation, so both in radians and degrees. So of course I started 0 degrees, go around 30, 45, 60, all the way to 360 degrees, and then the same with the radians. I kind of told you or alluded to the other video that I'd tell you a trick. The radians, the trick, and I'm not sure, I can't remember if Saul, the con video mentions it, but it's really talking about just fractional parts of a whole. So for instance, we know that the half of a circle, of the unit circle, is 1 pi radian. So it's pi radians. So if you think about it, you're breaking it up into parts. So the easiest one to think about is pi over 4, for instance. If you're breaking up this half a circle into 4 equal parts, that means pi over 4 is going to be at 45 degrees. Then halfway between is going to be pi over 2, so half of the pi, and then 3/4 of the pi, and then pi. So really you can count. You can say, hey, you know what? I know 45 degrees is pi over 4. Then the next one is 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is pi. And you can keep doing that all the way around the circle. So again, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi radians. Then if you keep going, and you know what? I forgot I have a highlighter. That might make it easier so you can see what the heck I'm trying to highlight here. Give me just a minute. I didn't want to do that. So let me just kind of show you what I'm talking about here. So this pi over 4, this is really 2 pi over 4, or pi over 2 if you reduce that fraction, 3 pi over 4, 4 pi over 4, which of course is pi, because 4 over 4 is just 1, 5 pi over 4, 6 pi over 4, if you reduce that fraction, 6 pi over 4, you get pi over 2, 3 pi over 2, 7 pi over 4, and then 8 pi over 4 is going to get you right back to 2 pi. So just kind of think about how the fractions work. It's really, and I know radians is still very fresh for y'all, but really it ends up being much, much easier than degrees. It's much easier to visualize and mathematically a lot easier to deal with. Let me show you about pi over 3, and I'm going to switch this over to, if I can, I don't know if this highlights differently, and let's try it. So pi over 3 is right here. So, and notice that's this one right here. So pi over 3, 2 pi over 3, 3 pi over 3. We're breaking it up into 3 equal pi pieces. So pi over 3, 2 pi over 3, 3 pi over 3. 4 pi over 3 is right here. 5 pi over 3. 6 pi over 3 gets you back to 2 pi. So again, it's just counting. Pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, and 6. Lastly is the pi over 6, and I really like pi over 6 because that's actually the one I tend to use. I don't do the pi's over 3's all the time in my head. I am going to do it in, I don't know, like this obnoxious green. This is pi over 6 right here. So pi over 6, 2 pi over 6 reduced as pi over 3. 3 pi over 6 is that, if you reduce it. 4 pi over 6, 5 pi over 6, 6 pi over 6, 7, 8, 9, 10 pi over 6 would reduce to 5 pi over 3, 11 pi over 6, and 12 pi over 6. Why do I show you this? Well, again, you're going to have to label these radians very quickly on a unit circle, and I'm just trying to give you some quick techniques rather than trying to memorize everything. Okay, so I'm going to get rid of all that so that I don't get any more clutter than I already am. So now let's talk about the points actually on the circle. And without getting too fancy again, you understand at this point where those points are coming from, but notice that everything in blue, here, 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 and here, are all the same values, but some of them are positive, some of them are negative. The reason that's happening, of course, is because anything in this quadrant right here, which is the first quadrant, is positive on the x and positive on the y. So any point in this quadrant is going to be positive, positive. So that's why the values all in this quadrant are positive. Over here, right here, you notice that, of course, the x is going to be negative because you're going in the negative part of the x-axis and up positive. So think about the good old days when you were just graphing points, you would go negative and then up positive. That's why, again, looking at these points on the unit circle, all the x coordinates are negative and all the y coordinates are positive. And that goes to figure here we have negative, negative in the third quadrant, and in the fourth quadrant going around is positive, negative. So all these values, let me try that again. All these values on the unit circle stem from this first quadrant. And if you can recognize this or know this first quadrant, thinking about those special triangles, then you can label the rest of the points very quickly. So again, square root of 3 over 2, 1/2 is over here. It's over here, here, and here. All four quadrants in the same position, just reflections of each other. And then you change the signs depending on which quadrant they're in. Same thing goes with the pi over 4s. So this one right here, notice this is the same thing as this, except for the signage depending on which quadrant it is, and same as this, and same as this. They're all the same, it's just whether they're positive or negative depending on the quadrant. And then lastly, of course, the pi over 3s. So the pi over 3s, again, another little trick, by the way, that I do is if you're getting confused with which one is 1/2 comma square root of 3 over 2, which point is that, versus the square root of 3 over 2 comma 1/2, the way I think about it is square root of 3 over 2 is a much bigger number. It's like 0.70. See, now I think it's 0.707. But anyway, it is a bigger number than 1/2. So when I'm still kind of calculating it really fast, sorry. Oh gosh, by the way, 0.707 is square root of 2 over 2. But so square root of 3 over 2 is actually 0.866, which is obviously much larger than 0.5, which is what 1/2 is. So the way I think about it is, if you're only going out a small way, but you're going way, way, way up to get to the point, then you're talking about the 1/2 going on your x-axis and square root of 3 over 2 on your y. If you look at, give me just a minute, if you look at this point right here, you're going a long way on the x-axis, which is why it's square root of 3 over 2, and up 1/2 on the y-axis. So that's how I remember which one's which. You know, there's all sorts of different little tricks, but those are a couple of mine. And that goes for all of this. There's all sorts of different little things to memorize things and to be able to fill this in. With that said, notice all the brown things going around my unit circle, and you can pause me at any time and fill yours in, but everything in brown is tangent, and we're going to talk about that here very soon. But I like making sure my tangents are already written on my unit circle, and of course that does involve a little bit of calculation, but it tends to save time then when you're filling out solutions. So speaking of that, let's kind of get into how we use that unit circle. I'm going to come right here to example 1. It says find the given values. By the way, all of this is no calculator. The unit circle in general you would have to do without a calculator as well. So it says find the given value, no calculator, of sine of 90 degrees. And how you do that is you're going to just rotate 90 degrees on your unit circle. You see that point is 0, 1. And of course the cosine of 90 degrees is 0 because that's the x-coordinate. The y-coordinate is the sine. So that means the sine of 90 degrees is equal to 1. And you know, you can use your calculator just to verify at this point to see if what I'm saying is true. That's always nice to check. Ooh, let me just 0, 1, and sine of 90 degrees is, yes. I'm kind of looking at my key. I have it in front of me, and I actually wrote the wrong answer. So that's why I'm kind of like looking at it going, anyway, so that is the value 1, and I'm changing on the key. What did I put? Oh, I put 1 or 0 by accident. Okay, so then this cosine of pi, so we know pi is 180 degrees, so we're going to rotate 180 degrees. Look at that point right here. This is the point I'm looking at right here. I know that this is the cosine of pi, and I know this value is the sine of pi. So it's asking for the cosine of pi, so what am I going to put? -1. So I'm going here, and I'm going to say that the solution, or the answer, is -1. The tan of 270, kind of taking that same idea, we're going all the way around to 270, which is right here. And again, you can do one of two things for tangent. We know that it's the y over the x. Tangent is always y over x. And you can say, hey, you know what? That's -1 over 0. So the y value is -1, the x is 0, and that is undefined. Notice I wrote it in brown already. That's where I got that value from. And that's why I'm writing here undefined. You can't put 0. 0 is the number 0. You need to write undefined. Doesn't exist. Sine of -90 degrees, not 90 degrees, sine of -90 degrees actually lands in that same spot we were just at, and we know that this right here is the cosine of -90 or 270 degrees. This is the sine, and that's what they're asking for, the sine at 270 degrees or -90 degrees. That means that this value is -1. So really, to get right down to it, all you're doing when you're evaluating value, sine, cosine, or tangent of a given angle without a calculator is you're using your unit circle. The cosine of that angle is going to be your x-coordinate, the sine of that angle is going to be your y-coordinate, and the tangent is the y over the x. Okay, or the sine of cosine, if you want to think of it that way. So here is example number 2. Again, just a reminder, no calculator. And then this is talking about from 0 to 360 degrees. It says find the values of theta. So now we're actually saying, hey, I want to know what the angle measure is. What is the angle from 0 to 360 degrees given the given function value? So I see sine theta equals 0. Now that does not mean theta is 0. That means the y-coordinate, this is the y-coordinate value, is 0, that you can find your sine value. So if you come up here and you look for all the y values that are 0, you notice it's right here So that would be 0 degrees, and then 180 degrees is the other one. Now you might think to yourself, well, what about 360 degrees? Well, let me first put 0 degrees here before I forget, and 180 degrees. The reason you do not put 360 degrees is you notice that the inequality is saying up to 360 but not actually equal 360. So it's actually is implying less than 360, but it can actually equal, notice that equal symbol on the 0 degrees. That's always the case. That's exactly how they always write it. So just kind of keep an eye on that, and that's the same thing that we do in pre-calculus. So it's just kind of a good habit to kind of note, but just want to make sure that you saw why it's not 360 degrees as well. Cosine of theta is equal to -1. If you look up at your unit circle, now keep in mind, now this cosine is dealing with the x-coordinate, so we are looking at where is x, -1. So I'm going to come up here, and I'm looking all the way around the unit circle at the x-coordinates, and it's -1 right here, and that is at 180 degrees. 180 degrees. So this actually becomes kind of fun and very straightforward once you understand what it is that you're looking at. As long as you can fill that unit circle out and you know how to use it, it becomes pretty straightforward. So again, this tangent of theta, remember this here is really the y over the x. So we're looking at when is it that the tangent of any given, or theta, is going to equal 0. And if you think about it, that needs to have a 0 in the numerator, and then of course it's a unit circle, so you can't have anything bigger than 1 or smaller than -1. So let's just put 1 as an example. So we're looking at when y, the y coordinate, is 0. You don't want the x coordinate to be 0 because that would make it undefined. So I'm going to come up here, and where is the y 0? It would be right at this spot here at 0 degrees. And again, also at 180. Notice that pi over 2, or excuse me, 90 degrees and 270 degrees is actually undefined. And again, you don't have to write the Brown information in. I just find it easier in the long run, and it's a good practice to get to know those tangents really quick as well. But anyway, so this here is going to be 0 and 180 degrees. Okay. So let's get into a little bit more with the unit circle. So cosine of 120 degrees. Now we're not just talking, I don't know if you noticed this, but example 1 and 2 was all about the axes. So it was either falling on the x-axis or the y-axis. So that 90 degrees, the 180, 270, and 360. But now we're talking about other points within that unit circle. So here we have the cosine of 120 degrees. If we come up here, we know the cosine of 120 degrees is right here. Cosine is dealing with the x coordinate, so that's where I'm going to write -1/2 right here, that -1/2. All right. And it can't be as simple as everything we've been doing, because cosine of -300 degrees, now we have to use everything we've learned in the past, which means -300 degrees is not 300 degrees, it's actually going to be symmetric across that x-axis, oops, if you want to think of it that way, but you're going clockwise. There we go, we're at 180, 270, and 300 is going to end up being right here. I'm going to try to move it so you can see it right here. There's 300 degrees. Notice positive 300 is over here, right here. Negative 300 degrees is over here. And that, or you can think of it as 60 degrees. Think about our coterminals, right? And cosine, of course, is the x-coordinate, looking at this point right here, which is 1/2. So I'm going to come down here. Actually, you guys are going to put that in, but I'm going to not have so much on my unit circle. It's already bad enough. Oops. Okay, so I have -1/2 there, and we have 1/2 here. So this here, I would expect you to be able to do on your own. So rotate around, find your 225 degrees. The tangent of 225 degrees, again, remember it's that y over the x. So look at your y value, your x value, and when you put it, and you notice it's square root of 2 over 2, over square root of 2 over 2, and that gives you 1. And I also wrote it up there for you. But that value is 1. Sine of negative 180 degrees, I expect you to be able to do that at this point. Rotate negative 180, look at the y-coordinate. This tangent of 300 degrees, let me show you how I came up with negative square root of 3. So obviously you can go on the unit circle. I put in brown all those values, but you need to know where those came from. So what I'm going to say is, okay, let's find tangent of 300 degrees. So the tangent of 300 degrees is right here. Actually, I could do better here. Let me just circle this right here. So notice it's negative square root of 3 over 2, so there's your y-coordinate, and 1/2. Or maybe what I'll do down here is write that coordinate down. 1/2 negative square root of 3 over 2. So once I show you the math steps to it, it's pretty straightforward. It's just kind of a little ugly. So again, we know that it's the y over the x, that's what the tangent is, and the x or the y-coordinate is negative square root of 3 over 2 at the 300 degrees, and the x is 1/2. Now here you have that double fraction, and I don't know how you think about it, but you can simplify it a couple different ways. But I notice in the denominators we both have 2's which divide out, and so you end up with negative square root of 3 over 1. So that's where I'm getting that negative square root of 3. 540 degrees, I would expect you to be able to track that down. So again, rotate 540 degrees. Of course, that's past the 360 degree mark, and you'll find that that's a pretty straightforward value. And again, remember it's cosine, so we're dealing with the x-coordinate. And this one as well, I would expect you to be able to do at this point. Now let's talk about radians, because radians, it's for you again, it's not as simple because you haven't seen it as much, but keep in mind we have them all listed on the unit circle. So when I say, hey, what is the sine of pi over 4, you can go to that unit circle, find pi over 4, which of course you should at this point know is in the first quadrant, and go, okay, I see that it's square root of 2 over 2 and square root of 2 over 2. And since I'm looking for the sine, well, the same thing actually, but the sine is going to be the y-coordinate, which is square root of 2 over 2. So you can do that same thing with cosine of negative pi over 2. That's going to give you, if you look at that unit circle, give you 0. And again, I'm kind of clipping along now because this is starting to become, I assume for some of you, a little redundant. Others of you, it might take a little longer. It takes different times to click for different students. But pause me so you have that time to look at the unit circle to see where I'm getting those values. Actually, I think I might do one different. Usually I check things in with you guys, but I'm going to actually give you these values of these ones that you're trying to find on your own, because here's the deal. I want to give you as much feedback as possible. You're going to be doing this enough as it is. So let me just write those answers down so that you can check to make sure you're doing them right. So this was one that I expect you to be able to do at this point, and I'll just tell you G is another one and H is another one. So I'll give you those answers in a minute, but let me go to 7 pi over 4. So again, this 5 pi over 4, you're just rotating around the unit circle, finding 5 pi over 4, and finding the y-coordinate and writing it down. Actually, you know what, I might as well do it. There just seems to be a lot of practice in this note guide as far as I'm concerned. 7 pi over 4. Okay, so let's talk about 7 pi over 4. We know that it's right here. It's this spot right here, 7 pi over 4. Again, that tangent is written already as -1, but remember, I'm putting the y-coordinate over the x-coordinate. That's where I got that brown value from. And so that's where right here it's going to be -1. But be leery. Don't just memorize things when it comes to the tangent. Know how to calculate that y over x. That makes it a lot easier. So 5 pi over 6, I can come over here, and again, for some of you, I know at this point you can figure this out very quickly. I'm rotating to 5 pi over 6. Here's the point I'm looking at. We're talking about the sine, which is the y-coordinate, so that is 1/2. And one more tangent here, just again to get you a little bit more practice. That tan of -3 pi over 2, that actually is rotating a -270 degrees if you want to think of it that way. But you're going to go around the unit circle. There's the negative pi, and this will be that -pi over 2, or 3 pi over 2, I'm sorry. So 3 pi over 2 ends up right here if you're going counterclockwise, which you usually do, but because it's negative, you're going clockwise up to the y-axis. And of course, if you're looking at putting the y over the x, and I'm going to list that point right here really quick, the point 0, 1, and if I'm putting y over x for this, we're putting 1 over 0, and that's, of course, undefined. Okay, and let me write these answers down for these. But again, just make sure you're doing them and doing them correctly. Okay, so we have finding the angles, looking at different parts of the unit circle. Again, this is from 0 to 360 degrees. And looking at and finding where the y-coordinate is square root of 3 over 2. Here you're going to find the x-coordinate is -1/2 because we're dealing with cosine versus sine, like the first problem here. And then tangent, of course, is the little more complicated one because that's y over x. So I'm going to first talk about square root of 3 over 2. So I come up here, square root of 3 over 2 is going to be, and again, we're looking at those y-coordinates. And so the very first one, if I'm rotating around the unit circle, where it happens is right here. Square root of 3 over 2, there's the y, that's square root of 3 over 2. So it's 60 degrees. And then the next one that's going to happen is going to be square root of 3 over 2 is the 120 degrees. Now there are two other versions of square root of 3 over 2, but they're negatives because of course they're on the third and fourth quadrant. So those are not the value square root of 3 over 2. So we're going to say 60 degrees and we're going to say 120 degrees. Now if you do the same thing with that cosine of -1/2, you'll see that the x-coordinate is going to be -1/2 only at 120 degrees and 240 degrees. So it's similar to what we did above. It's just now we're talking about rotations on the unit circle. Tangent theta equals -1. So we're trying to figure out when does y and x, when you put them over each other, give you -1. Now the first thing is, what would give you just 1? And that means the values would have to be the same, right? So we're talking about, you know, the pi over 4, the 3 pi over 4, and so on. So I'm looking over here, coming on up, and notice that this, if we put these over each other, they would be +1, which is why it says it in brown. Over here, notice that we do say that that's going to be -1 because one's positive, one's negative. Down here, right here, if you put those over each other, you're going to end up with +1 because they are both negative. And then, of course, we have this other one that's going to be -1, which is 315 degrees. So the two answers right here, and notice there's not just one answer for these, 135 degrees, and the other answer is 315 degrees. Okay, so looking down here, now it's the same. Now we're just dealing with from 0 to 2 pi, not equaling 2 pi, just less than 2 pi, but kind of like that 360 degrees that we talked about earlier. And so we're going on to the unit circle and looking at when we have a y-coordinate, because this is sine, that looks like that. And then not give it in degrees like we did above in example 5, but give it in radians. So you're just looking at the different piece of information. Here, this is of course the x value. Where does the x value equal negative square root of 3 over 2? And find that rotation in terms of radians, of course. So let me just write the answers down. Of course, you want to definitely make sure that you can see where these are coming from. 5 pi over 4 rotation, 7 pi over 4 rotation. That's a pi symbol. Oof, that's horrible. This is 5 pi over 6, and this is 7 pi over 6. And now the great thing about this tan of square root of 3, we do have them labeled in brown, but remember this is the y over x. Notice how that happens at pi over 3 and also for pi over 3. So please pause me a bunch of times here to look at your unit circle. But you know, this is a 30-minute video. I usually don't do that long of a video. So hopefully I was able to explain it well enough, give you some tricks to the unit circle. But folks, I got to tell you, practice makes perfect with the unit circle, and it is not going away. So you definitely want to feel very, very good about the unit circle. So thank you for tuning in, and we will answer any questions, or I will answer any questions you have in class. Take care.